Okay. Hi. Today my dad will be teaching you about review past
Regents
questions related to the history and experiments that contribute to the
evolution
of the atomic models.
Good luck.
Good luck.
Hi everyone. Alright, so many of these questions are going to deal with an experiment done by this man called Rutherford. And what Rutherford did was... Stop the clock.
I can't help it.
Okay. What Rutherford did was he took a box here and he put some radioactive material called alpha particles inside the box with a little small hole in it, so when the alpha particles escaped, they would head right for this piece of gold foil. Gold foil, very, very thin layer of gold atoms. In fact, so thin they're kind of represented here to the right as 1 atom, 2 atoms, 3 atoms, and so forth. Well, these alpha particles are positively charged, and they shot right at the gold foil, and remarkably they went through. So right away you got to think the atom itself is mostly empty space. Now let's focus a little bit on the idea of them being a positive charge. Well, as they went through, some of them were deflected either to the side, and in fact some of them were deflected right back at the box itself, suggesting that they must have come in contact with another substance that was positively charged. So taking a look at this picture here on the far right, let's zoom in on it a little bit, and here are the alpha particles streaming from the bottom to the top. Here in yellow with the dot are the gold atoms, suggesting here that most of them are going straight through. Now which ones are deflecting? The ones that actually hit some type of substance in the middle, which obviously also must have a positive charge, like charges repel. So Rutherford was able to postulate that not only were the atoms mostly empty space, but they in fact had some type of positive charge in the center of the atom, which he termed the nucleus. Hence, we start learning about the proton having a positive charge in the nucleus. What do you think of that?
Well, I didn't hear the whole entire thing.
Well, I hope my students did. And if you didn't, pause, rewind, and replay it. All right, we'll go on to the questions next. All right, question number 1. As a result of the gold foil experiment, as discussed just a moment ago, it was concluded that an atom, well, choice 1 says contains protons. That's kind of looking good. Neutrons, that's kind of ruining the answer. Neutrons were not discovered by this time. All right, so that eliminates choice number 1. Choice 2 contains a small, dense nucleus. The key here is nucleus. And in the previous slide where I showed you this picture down here, I failed to remind you that the nucleus is just about where all of the atom's mass is, so therefore it is a dense location. So it is going to be choice 2, but let's also look at 3 and 4. 3 mentioned something about a positron. Not even close to being discussed with Rutherford and his work. And 4 says is a hard indivisible sphere. That's a primitive understanding of the atom. So the best answer for number 1, the only answer for number 1 is choice 2. Okay, now this says, base your answer on question 2 and 3 on the information below. In the gold foil experiment, a thin sheet of gold was bombarded with alpha particles. Almost all the alpha particles passed straight through the foil. Only a few alpha particles were deflected from their original path. Again, this is described in the earlier portion of this video. If necessary, please rewind, go back to it, and review it. So let's move on to question number 2. So question 2 reads, explain in terms of charged particles why some of the alpha particles were deflected. So if we're talking about charged particles and the alpha particles themselves were a positive charge, they actually carry a positive too. That's something we'll discuss more in our nuclear chemistry unit, but they have a positive 2 charge. Now, if in fact this positive 2 charge is moving in a direction and then strikes something and gets deflected, well, whatever they came close to or struck must also be a positive charge. So, explain in terms of charged particles. So, let's talk about charged particles and realize it is very important here to use the term charged particles. So, what would I write? Well, I would probably write that the alpha particles were deflected because they struck or came near the positively charged protons, which is the particle, charged protons in the nucleus. Okay, and again, I would, let me choose a different color. I am mentioning here charged protons, and charged protons are charged particles. So that would be a perfectly acceptable answer. Number 3, state one conclusion about atomic structure based on the observations that almost all alpha particles pass straight through the gold foil. Taking a look here, now that we see that most of these alpha particles went straight through, it must be concluded that, let me grab a pen, one conclusion. One conclusion is the atom is mostly empty space. Question 4. Which conclusion was a direct result of the gold foil experiment? Choice 1. An atom is mostly empty space with a dense, positively charged nucleus. Now that sounds great because the previous questions really bring us there, but let's take a look at the others and see why they are wrong. Number 2 says an atom is composed of at least 3 types of subatomic particles. The neutron was not discovered yet, so that cannot be true. 3 says an electron has a positive charge. Wait a minute. Electron with a positive charge? That's wrong. 4, an electron has properties of both waves and particles. Where that is a true statement, that was not yet discovered. So keep that in mind for a later time. The answer is 1. 4 is true. Choice 2 is also true. But again, it can only be 1 because that was their best level of understanding at the time, and the gold foil experiment was responsible for it. Number 5. Which of these phrases best describes an atom? Number 1. A positive nucleus surrounded by a hard negative shell. Oh, come on. No. Let's get rid of that. 2. A positive nucleus surrounded by a cloud of negative charges. Sounds fairly decent. Let's look at 3. A hard sphere? A hard sphere? If the atom is mostly empty space, can't be a hard sphere. 4 also says a hard sphere, so let's get rid of that. Now the answer is 2, and let's take a look at this illustration to explain why. Here is one of the more modern models of the atom. where we have the nucleus. The nucleus has the protons and the neutrons. It is dense. It is where almost all the mass of the atom is. It is positively charged because the proton is positive, neutrons are neutral. And the electrons are out here in orbits, similar to the moon around the Earth or the Earth around the sun. But the thing is, it's kind of like a cloud because these electrons that sometimes could be in this orbit, but they also temporarily could be found in other orbits. But if you map out where they're found more frequently, and you map them out with dots as to where they are the most frequent, and you layer all those dots on top of each other, those dots end up making a scatter pattern like this, which resemble an orbit like this. So let's look at that once again. It says a positive nucleus surrounded by a cloud of negative charges, those negative charges being electrons. Number 6. Now this question piggybacks on the last one. It says, in an electron cloud model of the atom, an orbital is defined as the most probable, well, let's say, charge of an electron. An orbital, a charge? No, don't like it. Conductivity of an electron? Conductivity. Conductivity would relate to the ability to pass an electrical charge from one area to another, or the ability to pass on heat from one area to another. And it has absolutely nothing to do with that. Or most probable location of an electron, looking good, but most probable mass of an electron? One thing we have to know is the electron's mass is so small for our conversations, we ignore it. The mass of an electron for us in our class is 0. So it is not 4. The answer is 3. All right, question 7. In the late 1800s, experiments using cathode ray tubes led to the discovery of, well, let's take a look at a setup. Now, this was done by J.J. Thomson. He did his work before Rutherford, just so you know. Now, this is a cathode ray tube. They're really cool. You turn on the electricity, this high voltage supply, stream of electricity goes from here down to this plate, this metal plate, and there's another metal plate here, and this is a tube that has virtually no air in it, and they had a beam of light that would go straight across. Now what's interesting, most interesting about this is when they put a positively charged plate up here, this light bent towards the positive and away from the negative. Very similar to what a magnet might do, which would suggest that whatever was in this beam of light was negatively charged. And what they postulated from this work is that they found an electron. So in the late 1800s, back to the question, in the late 1800s, experiments using cathode ray tubes led to the discovery of the electron. Hope this helped.